Good evening, ladies, gentlemen, and scholars. I have fantastic news for you, and that is that today we are arriving at an extremely exciting point. It's section 3.c, solving systems with matrices, and take a look at what the essential question is. How can I solve a system of equations with any number of variables in about 30 seconds? Yes, I'm going to teach you a method to solve this guy in about 30 seconds, whereas previously it was a very involved process with many steps and many things could go wrong. Get your calculator out. This is one of those happy videos where I do have the calculator. All right, now I need to set up a couple things for you. First of all, we're going to be using matrices. And so I need to find a way to represent this set of equations with matrices, all right? So let's take an obvious step here and just kind of write it like it feels like it should be written. And here's what I mean by that. The right-hand side of the equation, doesn't this kind of look like a 2x1 matrix, 20 and 16? And that's exactly the matrix we're going to use. This side's a little more complicated, so let me set it up for you this way. Let's write it as a 2x1 matrix to start. So in the top, this like one entry, that top entry is 5x plus 7. This bottom entry is 3x plus 5. So this is all one entry, this is all one entry. This is still a 2x1 matrix. Now I'm going to do something and see if you can pick out what I did. This matrix is not particularly useful to us because it has all the numbers and all the variables mixed together. I really want to get two separate matrices, one with all the numbers, one with all the variables. So how about this? I'm going to put all of the coefficients here, and then I'm going to write the variable matrix like this. Do you see what I did there? Some of you might see it if I tell you that this is matrix multiplication. Think about the way that matrix multiplication works. Remember, in matrix multiplication, I'm multiplying this row times this column. So let's think what that would look like. To get the top entry in my new matrix, I'd have 5 times x plus 7 times y. Oh, look, that's this entry. Interesting. And for the bottom entry, wouldn't I need to multiply the bottom row times the column? 3 times x plus 5 times y. Oh, look, that's the second entry here. Interesting. So actually, as it turns out, if I want one of my matrices to be all variables, all I have to do is write the coefficients in one matrix and the variables in the next matrix, okay? And then we said that this was equal to 20 and 16. Now this is a very useful matrix for us because I can put this into my calculator and I can put this into my calculator and I will be able to solve it. So that's kind of foundational part one that I need to build for you. We have coefficient matrix. I'm going to label this as A. We have variable matrix that I'll label as X. We have like result matrix I'll label as B. Okay. Now, here's the deal. The reason I set things up like this is because we need to think of how we would solve a real life equation. And how we solve a real life equation is how we're going to solve this variable equation. So let's think of a really simple equation that looks like this. Something times the variable equals something. So let's say we do like 2x equals 6. Couldn't I just divide both sides by 2 to get that x equals 3? And that's awesome. So think about it. If I could just divide both sides by this matrix, wouldn't it cancel? This would cancel and this would cancel. I could divide the other side by that matrix and I'd be good to go. But here's the deal. Unfortunately, you're not able to divide matrices. There's just no way to divide them. So dividing doesn't make sense in this context. So let's go back to this equation. Instead of dividing by 2, how could I think of multiplying in such a way that makes sense? And I hope that you're thinking, hey, I could multiply by the reciprocal here. If I multiply both sides by 1/2, that will also cancel the 2 because 1/2 is the inverse of 2. Now I do know how to use matrix multiplication here. So here's what I'm going to do. Since I know how to do matrix multiplication but not matrix division, I have my matrix equation. If I multiply by the inverse of A, which is written like this, on both sides, it will cancel and I'll be left with just X. And this is matrix multiplication over here, which I know that I can do. Now, just real quick, I said some things in here that you didn't know about yet. First of all, what is this thing? This is the notation for the inverse of a matrix. What's that? Well, it's kind of the equivalent of like 2 and 1/2. These are inverses. A to the -1 is going to be the inverse of A, but in matrix land. And I could teach you how to do that, but I'm just going to tell you your calculator knows how to do this. So now it's time to switch over to calculator land, because I know that in order to solve this problem, what I need to do is I need to multiply both sides by A inverse. If I multiply both sides by A inverse, it's going to cancel here, and it's going to give me a result over on the right-hand side. So pull out your calculators. Many of you already know how to plug matrices into your calculators, but let me show you in case you don't. Turn it on. The matrix button is here. I'm going to hit second matrix. Here are all the matrices that I have at my disposal. I can hit enter to use them in different problems, but first I need to actually edit them. So I'm going to arrow to the right to edit. So let's edit matrix A. This is a 2x2 matrix for this problem. And so I literally just wrote 2x2 here, and it kind of adjusts to the right size. And let's put in the values. So I have 5, 7, 3, and 5. Okay, great. I'm going to hit second matrix. Clear. I'm going to hit second quit to get out of that. Then I'll go second matrix. Now we need to edit the B matrix. B in this case is a 2x1, and B is 20 and 16. Awesome. So I'll second quit out of that. My matrices are set. Now keep in mind, what we're doing is we're trying to see what is A inverse times B, because that is what X is going to equal. Remember, I'm multiplying both sides of the equation by the inverse of this matrix. When I do that, that will leave me with X, Y equals something. So it'll cancel here. I'll be left with just X, Y, and it'll give me an answer. Here's how you can use the calculator to do that. Hit second matrix. I'm using matrix A, so just hit enter. Notice that it puts matrix A right here. I know that I need to do matrix A inverse. That's the little x to the -1 button. Hit it. So A inverse times, and go back into matrix, select matrix B. So this is what I decided is going to solve the equation for me. A inverse times B. Let's hit enter, and look at that. It gives me a result matrix that makes so much sense. I have -3, 5 here, and look, X equals -3 and Y equals -5. I just solved this answer in like 30 seconds. Do you have to go through this every single time, this A to the -1 times B reasoning? No, you don't. This is how it's going to work for every single matrix multiplication problem. So all you have to do is take the coefficients. Remember, the coefficients came from here. Take this matrix, simply multiply the inverse of the coefficient matrix times B. That will give you the result. And I know that X equals -3. And Y equals 5. Fantastic. I can do it in about 30 seconds. Hey guys, thanks for watching so much. We'll talk more about this in class on Monday, and we'll practice working on these in super quick time. Thanks for watching.